Welcome to 3.9. Today's going to be a super useful section. In the box here, you see four formulas. Two of them you've seen before. These came from section 3.6, and these are generalizations of those two. These are new. So let's just look at some simple examples. The derivative of e to the 3x, we bring the 3 down and copy down e to the 3x. If we want the derivative of e to some more complicated function, u of x, then we leave a space and then we write down e to the u of x, x squared plus 4x, and in front we multiply by the derivative of the exponent, which is 2x plus 4. Now if I leave it like that, it's not correct because I want to multiply the exponential by all of this, so I need parentheses. Now the next one, I've got, instead of e to the x, I have the derivative of 3 to the x. So the derivative according to this formula is ln3 times 3 to the x. Okay, and the next one, almost the same, except this is if you have an exponent that's a function of x that's more complicated. So, for example, 4x, the derivative would be ln3 times the derivative of the exponent, which is 4, times 3 to the 4x. Okay, let's do a few more examples. First two you can do on your own. You should probably pause the video and do those. All right, so the first one, we're going to need product rule. So y prime is the derivative of the first, which is 1, times the second, e to the 4x, plus the first function, x, times the derivative of the second, which is 4 e to the 4x. Now, typically you don't want to leave an answer looking like that. First of all, this 1 here, we can get rid of. This is just the same as e to the 4x. Second, typically we take constants like 4 and put those in front. So this would be 4x e to the 4x. It's just typical math convention. And you don't know it unless someone tells you, so that's what I'm doing. Okay, next one, y prime is, we copy down e to the root x, and in front we put the derivative of root x, which is 1/2 x to the negative 1/2. And I'll clean that up. That's e to the root x over 2 root x. Pause, make sure you can follow that. Okay, derivatives of logarithms. These again are really easy formulas. Derivative of ln x is simply 1 over x. Now typically you won't find something that easy. You'll typically be taking the derivative of ln of a function of x, and in that case it's not too much more difficult. The formula is just u prime over u. Put the derivative of the argument up top and the argument below. If you have to take the derivative of a log with a different base, ln is base e. So if you have to take the derivative of maybe something with log base 2, you're going to change it to natural log using this formula. And we'll do examples of all of these. Okay, derivative of ln 3x. So y prime is u prime over u. U is 3x. So 3 over 3x. That's 1 over x. Actually, note that ln of any constant times x derivative is 1 over x. The constant cancels out, just like the 3 did. There's another way to take this derivative, which you probably don't want to do. I'm just showing you out of curiosity. Simplify y first using properties of logarithms. Y is ln 3 plus ln x. Now take the derivative. ln 3, that's a constant, so its derivative is 0, and the derivative of ln x is 1 over x. So you get the same answer. You probably want to do it this way, and after a while, you'll get used to writing this formula down directly. Okay, next one, we've got ln of a function of x, so we want to use the formula over here in the box, u prime over u for the derivative. So y prime, on top I put u prime, 6x squared plus 4, and on the bottom I put u, which is the argument, 2x cubed plus 4x. Okay, so that's our y prime. Next one, we've got logarithm to a different base. So the first thing we want to do is change y to the natural logarithm using the formula you see over here in this box. So y equals, not y prime, y equals ln x over ln 2. Now we can take the derivative. ln 2 is a constant, so this is the same, y is the same as 1 over ln 2 times ln x. So we don't need the quotient rule. y prime is 1 over ln 2, that's a constant, and the derivative of ln x is 1 over x. And if I want to write that as a single fraction, which I do, that would be 1 over, I'm going to put the x in front so I don't need to use parentheses and write it like that. Next one, you should pause, try this one. Hopefully you did that. Y prime equals, the derivative of sine is cosine. This is going to be the chain rule. So 2 cos, leave the inside fixed, ln x, then multiply by the derivative of the inside, which is 1 over x. And I'll write that as a fraction, 2 cos of ln x over x. All right, next one, we want to work smart, not hard. I could take the derivative using the u prime over u, but the u prime is going to be pretty complex. It's going to have quotient rule and chain rule. So what I'll do is keep writing y here, because I'm not going to take the derivative yet. I'm going to use properties of logarithms to simplify this. Square root is the same as exponent 1/2, and we know we can take an exponent and move it out front. So this is ln 3x plus 2 over 3x minus 2 with a 1/2 out front, because I had the 1/2 up here and I moved it down there. That's what happened. Now we're going to go a little bit further. This is 1/2, put a bracket here, ln of the numerator, 3x plus 2, minus ln of the denominator, 3x minus 2. Now, using the properties of logarithms, this is as far as we can go. Can't go any further, so we're now ready to take y prime. So now I'm changing to y prime. Y prime equals 1/2. In the brackets, we'll take the derivative. I want to use the formula u prime over u. So in this case, u prime is 3, 3x plus 2 is u, and then subtract 3 over 3x minus 2. It's a super quick way to find that derivative without having to use a bunch of chain rules. Okay, and that brings us to logarithmic differentiation, which is a way to find the derivative of either f of x to the g of x, or y equals a complicated algebraic function. And so that's my example here, a complicated algebraic function. We could take the derivative using product and chain rules, but this is just another way to do it. So the first step is to take natural log of both sides, and I did that. And part of also the first step is to simplify. So this is ln y. I'm going to use properties of logs. This is ln of 2x plus 4 to the 7th plus ln of x squared minus 1 cubed. And that's 7 ln of 2x plus 4 plus 3 ln of x squared minus 1. So that's the end of step 1. Step 2 is to take d by dx of both sides. So on the left, I want d by dx of ln y, and on the right, I want d by dx of everything I have written in the line above. Okay, now on the left, for the derivative of ln y, I want to think of this as implicit differentiation. I take 1 over y, and then I multiply by the derivative of the inside, which is y prime. So when you do logarithmic differentiation, the derivative on the left will always be 1 over y times y prime. Now on this side, we get 14 over 2x plus 4. I'm multiplying the 7 and the 2 in my head, plus 6x over x squared minus 1. All right, and step 3 is to solve for y prime. So I'm going to multiply both sides by y. Y prime equals 14 over 2x plus 4 plus 6x over x squared minus 1 times y. However, I know what y is. That's at the very top. Y is 2x plus 4 to the 7th times x squared minus 1 cubed. So I'm able to write my answer completely in terms of x. And there it is. Okay, you only have one homework problem involving logarithmic differentiation, but it's good to know how to use it when you need it. And that is the end of this section.